This is for 11 methods. We're going to look at question 15 from exercise 2H. So this is a speed type question. We've got Anne and Maureen. They live in a town which is they live in towns which is 57 kilometers apart. Anne sets out 9 a.m. one day to ride her bike to Maureen's place at a constant speed of 20 kilometers per hour. At the same time, Maureen sets out to ride at Anne's place at a constant speed of 18 kilometers per hour. Write down the rule for the distance of each of them from Anne's place. That's key. From Anne's place. T's in minutes after 9 a.m. Now, can you see that we've got a problem already? Because all our speeds given are in kilometers per hour, not minutes. So we've got to convert the unit conversion. If I want to convert 20 kilometers per hour to minutes, we know that it's 60 minutes an hour, so that's a third kilometers per minute. Similarly, 18 kilometers per hour would be 18 kilometers divided by 60 minutes. So that's 0.3 kilometers per minute. So you got to be really careful with speed questions to make sure your units are consistent. So write down the rule for the distance D for each of them. Okay, so since we're traveling from Anne's place, the distance for Anne would just be a third times T. Okay. The reason is, remember the distance, speed, time triangle. Distance is speed times time. My speed is a third kilometers per minute. My time is just T. So that's why the equation's like that. So we've got a third T. The distance for Maureen is a bit more complicated because Maureen, if Anne's here, Maureen's there. If I'm traveling this way, that's positive. But if I'm traveling backwards, it's negative. Okay. Now, Maureen, we know that the distance between Anne and Maureen's place is 57. So Maureen originally, at the very start, is 57 kilometers away from Anne. Okay, so that's like the line set. Then she quickly moves to Anne's place, so her distance is getting closer to Anne. So she's traveling at 0.3 kilometers, 0.3 kilometers per minute for every minute closer to Anne's place. So she started at 57 kilometers, then she slowly moves at 0.3 kilometers per minute to Anne's place. So once she gets to Anne's place, obviously her distance will be 0. Okay, so that's why the equation's like that. So for part B, we want to sketch the graphs on the same set of axes. But first of all, I need to find the time at which they meet. Okay, and to do that, I use the CAS calculator. So I'm going to go simultaneous. So y equals a third x and y equals 57 minus 0.3 x, and I'm solving for x, y. So we can see that they're going to meet at 90 minutes and at a distance of 30 kilometers. Okay, so for part C, so I'm going to do part C first. We know that they're going to t equals 90, d equals 30. So 90, 30 is my point of intersection. So find the time which they meet. So 90 minutes would be your answer. For part B, I want to draw the graphs on the same set of axes. I know that this is my distance, this is my time. Now, N is just going to start at 0 and move away. Okay. Now, Maureen will start at 57 kilometers away from Anne, then move slowly to 0. So we've got to find that point of intersection point. So that's 90, 30. And that's pretty much all we have to do for that type of question. It doesn't necessarily ask us to label the input, so I'm not going to do that. Part D, how far has each of them traveled when they meet? So for Anne, we know she's traveled, she's traveled 30 kilometers because that's what the point of intersection says. However, for Maureen, it's a bit different, okay? Because she was initially 57 kilometers away. if she traveled 30 kilometers less, then that means she is at 27 kilometers. So she must have traveled 27 kilometers. Okay. So that's basically how you do this type of question. Okay. So it's really important that you pay attention to small details like these, like whether something's in kilometers or in, in hours or minutes. Check your units consistent before even attempting the question. And setting up the equation, you've got to think about carefully about where your reference point for speed is. Okay, so in this case, N is the starting point. N's place is the starting point. So marine, by definition, would start at 57 kilometers and then go to 0. So hopefully that helps.